In part one of this two-part series about the supposed end of the civilized world, I looked at how alarmists were going wild over a classified CIA document that turned out to be a self-published booklet based on biblical verses which has been freely available for 60 years. Ben Davidson from Suspicious Observers gives us its alarming predictions.
The mighty Pacific rears back and piles up into a mountain of water more than 2 miles high.
And supersonic 1,000-mile-an-hour winds and so on. The link to that video is in this video description. But I didn't have time to look at the imaginary cause of these catastrophic events. Apparently it has something to do with the Earth flipping onto its side because of a reversal of the Earth's magnetic field. So at the end of that video, I said this. So in part two, I'll look at how they think the Earth flipped over onto its side and explore the idea that the Earth's magnetic field switches polarity every few thousand years and causes cataclysms and extinctions. Are we overdue for another one? Will it bring the apocalypse? All right, that's enough. Don't take over the show. So is the Earth's magnetic field about to flip polarity? Are we overdue for another one? Will it cause a catastrophe? Well, there's only one way to find out. Ask a geophysicist this question.
So what's the science behind this complete reversal of the magnetic pole?
Except for some reason, Joe Rogan didn't ask a geophysicist. He asked some guy with an MBA in marketing. Well, who knows? Maybe when Anglo-American wants to do electrical resistivity tomography at a potential mining site, they don't use geophysicists. They call in the guys from the marketing department. Yeah, that makes sense. But it turns out this particular marketing expert, surprisingly, doesn't know that much about geophysics. But that doesn't stop him thinking he knows more than experts who've actually studied the subject.
They don't know what they're talking about because they claim that the geomagnetic pole shift is because of the interior, whether it's the iron core or whatever it is, the molten core, does a shift.
Oh, is that what's written in all those sciencey papers? The geomagnetic pole shift is because of the interior, whether it's iron core, whatever it is, the molten core does a shift. Not surprisingly, the science is a little more complicated than that, but why spend time at university studying this difficult subject and getting a PhD when you can simply start a YouTube channel and claim you know better?
This is one of several times MIT has simply gotten it wrong.
Yes, those silly geophysicists at MIT have gotten it wrong, says the guy who studied economics and law. Look, I've got nothing against lawyers and marketing guys. That's obviously not the reason we know they're wrong. And it's not because of their personality or their intelligence. That would be a silly ad hominem argument that has no place in a discussion about science. The reason we know they're wrong is because they sometimes do reference science, and when they do, it's very easy to show where they made a mistake. And that's what we're going to do in this video. So watch the video before you start writing those boringly predictable comments that this is all just ad hominem. This is about plain and simple facts. But to kick things off, let's ignore what the alarmists think researchers say and find out what they actually say. The Earth's magnetic field is generated in the outer core, which is mostly molten iron and nickel. The molten material is moved around by the spin of the mantle on one side and the spin of the solid iron inner core on the other. In addition, there are movements perpendicular to that, caused by lighter particles created and then rising up from the inner core boundary. And there are thermal currents taking hot material from near the ICB towards the mantle and cooler material in the opposite direction. All this movement creates free electrons, and as you know from junior high school science, moving electrons create a magnetic field. We feel a tiny fraction of this magnetic field at the surface, but it's equally chaotic. It looks like this in junior high school textbooks, but in reality the magnetic field looks more like this, and it's constantly moving and changing. And just as we learned in school, when the direction of the electrical current changes, as it sometimes does in a chaotic system, the net effect is to change the polarity. Now, what's this going to do to us? The Earth depends on its magnetic field to shield against cosmic rays, so as the magnetic field weakens prior to a polarity reversal, it's likely we'll be subjected to more ionizing radiation. That's really bad for us today because we depend on telecommunications. But there's not much evidence of any disruption to the natural environment, according to the geological record. Polar shifts have happened all the time, with no discernible effect. One exception is a study in Australia that found some evidence of climate shifts during a weakening of the magnetic field 42,000 years ago. That may have led to environmental changes and extinctions. Whether that's causation or just coincidence, it's all a bit boring for the alarmists because there are no 1,000-mile-an-hour winds or 2-mile-high tsunami. So Ben Davidson of Suspicious Observers instead turns away from the science and prefers to read a 1994 book called World in Peril. Oh, I'm sorry, I mean World in Peril! By someone called Ken White, who imagined a much more exciting version of events.
It was concluded that Earth's magnetic pole began slowly accelerating, followed by a whip around the geographic polar region, which somehow tilts the planet back and forth.
Yeah, the crust of the Earth is a single solid sphere that slips around 90 degrees, somehow. The somehow part, however, is pretty crucial, and Ben doesn't like to go into detail, for good reason. According to World in Peril, the Earth's crust is magnetic, so it gets dragged around by the magnetic field. If the magnetic field flips over completely, the crust flips over with it, much as a rotating magnet draws iron filings, White explains. White offers support for this idea from experiments supposedly conducted at the Rand Corporation in the late 1940s. But he offers no record of these experiments, or any publication, or a detailed description of what the experiments were. Even if some sort of experiment was conducted, it clearly failed because, for starters, the Earth's crust isn't magnetic. Over 80% of the crust comprises oxygen, aluminium and silicon, or if you prefer, aluminum. The iron content is only 6%. Would that be enough to attract a powerful magnet? Clearly not. This lump of Torridon sandstone from Scotland is iron-rich, and the rare earth magnet I'm holding is about 4,000 Gauss, 8,000 times stronger than the Earth's magnetic field. And yet the rock can't even hold the magnet, let alone get dragged along by it. Come on. Fans of Suspicious Observers can try this themselves. If a strong magnet can't do it, the incredibly weak magnetic field that surrounds us has no chance. Come on, Rob. In fact, we already know the Earth's crust doesn't get dragged around by a moving magnetic field because the magnetic poles have moved hundreds of kilometers over the last few decades and not moved the crust a single inch.
Let's tilt Greenland down to the equator. That makes this the new equator, approximately, in this case. Antarctica would be on the other side, still on the equator, but in both Greenland and Antarctica, the great melt begins.
So if this has happened every 12,000 years, as the book claims, why don't we see evidence of this huge melt in the geological record? Why don't we find regular layers of flooded sediment containing the remains of dead moose and polar bears who somehow managed to evolve every 12,000 years? And if all the tropical forests and animals that live in them moved to the North Pole every 12,000 years and got buried under ice, why don't we find them when we drill through ice cores going back 60,000 years? To put it in layman's terms, if my wife phoned to tell me a tsunami had just flooded the house and I rushed back to find the living room looking like this, I might be a teeny bit skeptical. Major events like these leave evidence. So what evidence does Jimmy Corsetti have for his regular catastrophes?
Well, I showed you the Emikusi volcano in Africa in the Sahara, which is at 11,300 feet, that has salt as well as evidence of gastropods, sea life.
Yeah, you did show us this, but as we saw in part 1, you got this from a Wikipedia page, which you misread. Where Wikipedia said carbonate salts, Corsetti thought that meant sea salt. And he thought lake-dwelling gastropods lived in the sea. Again, it's not the fact that Jimmy Corsetti studied marketing rather than science that makes him wrong. It's his misreporting of what's clearly written on the page. But his lack of education in science does at least explain why he got it wrong, why he uses Wikipedia as a source rather than the studies that the Wikipedia page is based on, and why he misunderstands simple scientific terms like lacustrine and sodium carbonate.
They don't know what they're talking about.
I know it sounds ludicrous that a grand theory about the end of civilization that millions of people believe can come from a misreading of a Wikipedia page, but welcome to the internet age, a tool that started with such promise as a new and exciting learning experience and ended up as the Joe Rogan experience. As well as 2-mile-high tsunami and tropical animals getting buried under Arctic ice, the magnetic flip is also supposed to produce
faults and volcanoes, massive collisions and crimping of the crustal portions, with others breaking open to the fire beneath.
Yeah, all that. So again, where are they? We can see the magnetic flips, they're recorded in the rocks, because small magnetic particles in magma or lava align with the magnetic field as the molten rock solidifies. But Ben Davidson can't point to a single example of one of these massive continental collisions and opening up of the crust of the fire beneath. That sort of thing would leave a mark. Now, posters in the comments section will of course say, but you can see these marks all over the Earth. We see faults and mountains and solidified sheets of volcanic lava. And Ben could try to argue that too. But they won't point to a specific example, like this mountain chain, the Pyrenees, or these sheets of lava in central India. Because if they did, it would be very easy to check the studies associated with these features to find out when and how they formed. The Pyrenees, for example, is the result of a tectonic collision between Spain and France that happened over millions of years. These sheets of lava are part of the Deccan traps that were laid down during a flood basalt event, again, over millions of years. Nearly all the major orogenic and volcanic features on Earth have been studied, and so far none of them occurs in the space of a few hundred years, let alone a few hours. They all happened over a long period of time, and their origins weren't coincidental with magnetic reversals. But Jimmy Corsetti has a good question.
So I'm like, if you're saying that the interior that is molten does a shift, why on earth would you suggest that it wouldn't cause earthquakes or volcanic activity on the surface?
Because, for starters, no one is saying that polarity reversals are the result of the Earth's core doing a shift. That's just what Corsetti thinks is in the scientific literature. Secondly, earthquakes and volcanic activity are associated with crustal plate movements, not the Earth's core. And again, there's no evidence of any earthquake or volcanic activity associated with magnetic pole reversals in the past. And while we're at it, let's blow away the claim that the Earth is going to suddenly stop rotating.
The Earth essentially does a standstill. The sun will basically stay in the same spot, causing heating like we've never experienced, and that the wind and the waters continue with their momentum.
Survivors there marvel at the sun standing still in the sky for nearly half a day.
The survivors are presumably those who survived being thrown sideways at 1,000 kilometers an hour, along with oceans, wind, animals, rocks, and anything else that isn't pinned down. Apart from the fact that we'd easily spot this mass extinction every 12,000 years in the geological record, there's the problem of inertia. If a bunch of kids is going round a carousel and you want to stop it, you have to apply a force to do that. In this case, it's called a torque, because we're dealing with rotation. To stop an entire planet from spinning, the torque would need to be huge. So where does this force come from? We're not told. Neither do we get to see any calculations. A lot of these YouTubers play around with planets as if they were basketballs.
Let's tilt Greenland down to the equator. That makes this the new equator.
As Neil Adams said when he tried to defend his idea that the Earth was expanding, think up the concept first, then verify with math. Except that neither Adams nor any of the others who expand, squeeze, tip, slow down and speed up the Earth have ever got around to showing us any calculations. All we hear are the concepts. So let's see whether any of the physics is possible by applying some simple equations. Now let me start by saying that unlike a lot of these YouTube alarmists, I make no pretensions to being smart. Even though this is fairly basic high school physics, I've probably made some errors that my subscribers will point out, so look out for corrections on the video description. The moment of inertia of a rotating sphere is defined by this formula. So if we substitute the approximate mass and radius of the Earth, we get a moment of inertia of roughly 4.8 times 10 to the power 38 kilogram meters squared. So what amount of torque would be needed to slow this down over a period of a few hours? To get the answer, we need to multiply this by the angular velocity divided by the time taken to arrest the spin. Let's say 10 hours, 36,000 seconds, which is roughly in line with the concept that the Earth shuddered to a halt in a few hours. Substituting those figures gives us a torque of around 3.5 times 10 to the 34 Newton meters per second. That's 3.5 billion trillion Newton meters per second, or if you put it in non-scientific terms, a shitload. Now that Davidson and Corsetti know what torque is needed to stop the Earth rotating, perhaps they can explain where this enormous force comes from. Ben Davidson thinks it can come from a huge solar flare known as an X100.
But surely the sun couldn't affect the Earth's rotation, right?
By the way, Ben's using a familiar courtroom rhetorical technique here, because the answers to his questions are obviously yes, it can, of course they have, and no, it isn't.
The mere concept seems so foreign that surely no NASA scientists or university professors have published on the topic. Surely you couldn't find dozens of papers on that topic going back decades, and surely if something like a solar storm could affect Earth's rotation, imagine what a superflare in the X100 range could do, something possible on 800 to 2,000 year timescales. And then, imagine what the micronova could do. Surely, such a connection between the sun and the spin which we take for granted every day is impossible, right?
No, it isn't.
And don't call me Shirley.
So, do these papers really show that solar storms have an effect on the Earth's rotation? Yes, they do, but wait till you find out how much.
The mere concept seems so foreign that...
This paper by Del Rio measures the variation in Earth's rotation due to the 11-year solar cycle over a period of 300 years. Most of the time there was no recordable change. The variation they did find in a few of those cycles was less than 0.5 milliseconds, 1/2000th of a second. Certainly not noticeable.
Surely no NASA scientists or university professors have published on the topic.
In this paper cited by Ben, the variation is less than 4 milliseconds.
Surely you couldn't find dozens of papers on that topic going back decades, and...
I could only find an abstract of this paper, but then so could Ben, so neither of us knows what the figure is.
Surely if something like a solar storm could affect Earth's rotation...
This paper cited by Ben measured less than 1 millisecond.
Imagine what a superflare in the X100 range could do.
This paper cited by Ben, less than 5 milliseconds.
Something possible on 800 to 2,000 year timescales.
And this paper cited by Ben, less than 1 millisecond. So while Ben's correct in saying that these solar storms affect the Earth's rotation, he doesn't mention that the effect is less than 5 milliseconds. He simply tells his audience that the effect is what he calls noticeable, which it certainly isn't, and then asks people to imagine, again without reference to figures, what would happen if we had a superflare. Well, no need to imagine, let's just look at the figures. A superflare is a rare event, thousands of times the size of a typical solar flare. So, rule of thumb, if a huge solar flare can slow the Earth down by around a millisecond, then a superflare 10,000 times bigger would slow it down by around 10,000 milliseconds. That's 10 seconds. Definitely a noticeable amount, but nowhere near stopping the Earth's rotation. That's why Ben vaguely asks you to imagine what it would do.
Imagine the effect of a superflare or micronova.
Rather than work it out and tell you. Even without this back-of-the-envelope calculation, we know that superflares don't stop the Earth because they've happened before. About 9,000 years ago, and 7,000 years ago, and 1,200 years ago. Not surprisingly, the Earth didn't stop spinning, and people didn't shoot sideways at 1,000 miles an hour. So that brings us to the next obvious question.
And are there any estimates on when this could possibly take place?
According to Ben Davidson, it's already happening.
Earth's magnetic reversal has been underway for more than 100 years.
Now, the modern Earth's magnetic shift actually began about 160 some years ago, so we are already definitely in the red zone.
Definitely? But no one who actually researches this subject is claiming we're in the middle of a polarity reversal. So what does Ben Davidson know that they don't?
The magnetic poles are shifting faster and faster.
Back in just the 1990s, it was traveling, the North Pole was transitioning at 10 miles a year. Now it's at 40 or almost 40 miles. It's accelerating.
But geophysicists already know this. They're the ones who measure these changes. Why does that mean we're in the middle of a magnetic polarity reversal? After all, the magnetic poles move around a lot. Sometimes they slow down, sometimes they speed up. It's a chaotic system.
Earth's magnetic field is weakening as well.
Okay, but again, why does that mean we've started a polarity reversal? A paleoreconstruction of the dipole moment shows that the field has often strengthened and weakened at the same rate as today. That rarely leads to a reversal. In fact, the magnetic field has only weakened about 9%, and by historical standards, it's much stronger than average. Unfortunately, Ben Davidson's claim that this weakening of the magnetic field is evidence we must have started a polarity reversal is somewhat undermined by another suspicious observer's video in which he said this.
The current strength of the field has absolutely no bearing on when it's reversing.
Okay, I don't know which of these positions Ben wants to take, but let's go with the second one. The evidence suggests that reversals are preceded by a weakening of the magnetic field. It's just that not every weakening of the magnetic field leads to a reversal. So, whichever of the two contrary positions Ben wants to take, neither is in accord with the science. The bottom line is that there's nothing unusual about the behavior of the Earth's magnetic field right now, and no evidence to suggest it's heralding a reversal of magnetic polarity. But that doesn't mean it can't happen tomorrow, according to Jimmy Corsetti.
The day that it happens, you could potentially see the compass slowly moving. And then when you go back to this Adam and Eve story talking about the pole shift, they say that the event happens in approximately a quarter of a day, so 6 hours.
But remember, the Adam and Eve story is a self-published booklet based on biblical verses. According to scientific studies that aren't based on Bronze Age mythology, these reversals take hundreds, if not thousands, of years to complete. The last one took 22,000 years. Even the fastest of them, described as quick, takes an entire human lifetime. So no, you're not going to wake up one morning and see the compass slowly moving as the poles completely reverse before lunch. That leaves just one argument, that we're somehow overdue for a polarity reversal.
They say that the last one was like 778,000 years ago, and we're like something like 200,000 years overdue.
Well, that assumes that there's some kind of regularity to these reverses that determines a due date for when it will happen next. But of course, this is a chaotic system. That means there's no way of predicting when these magnetic reversals will happen. Sometimes it takes just a few thousand years, sometimes it takes 10 million years. So it could be millions of years before we get the next one. Why do these YouTubers say it's overdue? Well, if you divide a given number of years, 83 million in this NASA example, by the number of known polarity reversals during that period, 183, you get an average, a figure of about 453,000 years. So catastrophists figure that if the last one was 780,000 years ago, the next one should have happened over 300,000 years ago and is now overdue. It's the kind of skewed logic that ensures casinos always make money. Why? Well, take the roulette wheel as an example of a random and unpredictable system. A gambler thinks he can beat it. He goes to the casino every day for years and counts the number of times the roulette wheel is turned and the number of times the number 2 comes up. Sometimes it takes hundreds of spins before a 2 is called. Sometimes it comes up twice in a couple of minutes. But he divides one figure, 8,000 spins, by the other to get the average. The average is close to 37, of course, because there are 37 slots on the wheel, and therefore a 1 in 37 chance that the number 2 will come up. Now that he knows the odds, he can take on the casino. He brings a bucket full of chips and watches as the first ball rolls. He knows he isn't due for a win right from the start, so he holds off. But after about an hour, the wheel has been spun 37 times. At last he thinks it's due for a 2. The odds are now dramatically in his favour, and he starts betting. So, is he right? If a particular number hasn't come up, does that mean the chances of it coming up now are greatly improved? No, of course not. That's a load of number 2. The odds are still 1 in 37. There's no such thing as overdue in a random system. The persistent gambler's idea that they're due for a win is why they always lose.
Is because if the Adam and Eve story, if the details discussed in it are accurate, the reason why we're not seeing the evidence of it is because it flips right back and thus masks the evidence that it ever happened. So it's pretty wild.
You guys are freaking me the fuck out, man.
Yeah, shut up. You're freaking out poor old Joe Rogan. But go ahead, Jimmy. I'll let you have the last word.
So this is science.
Saya membutuhkan hutan karena bahan bakunya banyak di hutan. Saya sering mengambil bambu, rotan dari hutan.
Another big difference between me and these other YouTubers is that I haven't monetized my channel, I don't have a Patreon account, and I don't ask for money. If you want to support this channel, please support a charity that I endorse called Health in Harmony.
Dan buah-buahan, itu juga masyarakat di sini sepakat,
which provides healthcare in poor countries in exchange for forest protection.
Pernah terjadi bencana alam seperti longsor.
The result is better healthcare for poor families, an improvement in their environment, and benefits for the rest of us by stopping deforestation. Details are in the video description, and thanks to all those who've donated.
Itulah saya takut itu hilang dampaknya, tidak ada apa-apa lagi. Jadi itulah yang saya terus memelihara hutan, saling kompak sama masyarakat.